In this video, we will explore the Fitter module in Fitteia used for simulating laboratory sessions. To access the module, open any folder in Fitteia such as the available system folder, which will you take to basic submodule. On right side, advanced options like expert and master are available for adjusting multiple data sets simultaneously. The Fitter layout is divided into three main parts. So the one for entering experimental data, another is controlling the display for data, and third area is where you write the function, your function that you want to adjust. For example, imagine that you want to determine the spring constant for a spring. A very simple way to achieve this experimental would be to associate different masses with spring and measurement the corresponding variations in length. Then the data of variation in length as a function of the mass, you could adjust a straight line, and the slope of the straight line will depend on spring constant k that you would to be determined. Now that third area is already prepared for use to do this. The equation that programmed here already the equation of a straight line. However, it is always policy to change the name of variables and parameters so that they can more quickly relate it to parameters of the problem that you can dealing with. So x become m and y can become l to represent the variation in length. The variable parameter b, which is the slope of the line, is not directly the elastic constant that you to determine. So it is much better to write g here over k. Because that way you can determine the elastic constant directly from the adjustment, and you do not need to doing calculate with b and propagation the uncertainty of b to various of value of k. We could leave as it, but it make it agree with the equation that we have above. We will change it to d naught. Note that if I now to compile in this condition, as I mentioned the variables and function, it get a compilation error. You can see it. And if I go to the file here, it will give me some error message because of parameter that I changed. D naught, G and K are not declared. A and B are still declared. So here in the box, you have to write separate by commas the new adjustment parameter. When you do compile again, you will that a new area appear. Here we have this graph that represents these points that are by default whenever we enter the fitter module, and which by the way have nothing to do with the experiment to determine the spring constant. Here we have the table of the parameter. We can see parameter that we choose, and here we have directly the constant and we want to determine. And the fact that this area appeared is already a good indicator that the compilation was successful. But we can go back down here and we have the message compiled without error. Regarding the experimental data, you have to put them in this box, in big box. The first column is independent variable. In this case, it would be the masses. And the second column is dependent variable, therefore the variation in the length. And the third column is the uncertainty, the dependent variable. In the laboratory, it can happen that the point are not acquired under the best conditions, and you may want to reduce some of these points or not consider them in the adjustment. It never a good policy to simple delete these points and one by one do not consider a point. In the adjustment is to start representing with this hash. This is the way to comment a line in this box. When we do a data plot, you see the graph now no longer the second point, because we consider a second point as a comment line and it has been suppressed. It will not consider in the adjustment, but it has not been eliminated. So it remains in the box and we can still go back and recover it. Let's restore. Here below you have a small calculator and always to perform operation with column. The first operation I will to do keep column 1, therefore C lowercase 1 keep column 2 space C lowercase 2, and I am not going to write anything else. That is the third column will be eliminated when I loaded calculated. So we get 4 error message in the upside of the window. Therefore, uncertainty of dependent variable is missing. To reserve the I did it, I1 can do 0.1 because what was this column was uncertainty always equal to 0.1. And when I do with the calculator, you see I recover with the table and I had at beginning. You can see using calculator to do, for example, conversation or variable sum of these column. Imagine that the length of the miring in the lab or in centimeter. You can go here and column 2 and multiply then 10 raised to power minus 2. Let's do and the same thing with uncertainty. Instead, we'll multiply, for example, by 2 raised to power minus 2, and you can do operation directly with the value that are here in the table. For example, let's add 0.1. So, yeah, let's now I want to click on my data plot. It was the most affected by conversation I made from centimeters to meter. We can use the auto scaling option on the right side to recover our graph, where you can see the 4 point and where they are perfectly apparent. However, this option never generate a representation that is suitable for presenting a report or logbook. Therefore, after doing the auto scaling, there should always be refinement for the parameters. You can see the graph. So auto scaling is necessary to show your graph as you want. Here we have the auto scaling option, and we can select yes and auto scaling option of our y. We can also choose the option yes or no. Downside is x label is the our in our case the x label is the mass. So don't forget to write the unit. So I will write here is so mass with the unit, and the y variable is the length. So I will label it with delta d naught backslash 8 to Greek letter environment, and the delta with the capital D, and return to environment that by default it is in the filter. We do a backslash 4. And there is another option is the maximum and minimum. So we will change the value as we want to according to our representation of our graph. So then I click on data plot. So you can see it, our graph is changed according to our changing, and label is also mentioned with some units, m with kilogram and delta am, and there are some units from 0.00 to 5 on the x-axis, and other is 0.00 to 0.005. So I will change my values with the minimum and maximum, and also I can change the precision and then click on the data plot. So on the x-axis I get values from 0 to 5. On the y-axis I get values in points by changing my values. So I also can click on the n subtricts. So now I select the two option and then click again on the data plot. So you can see there is a two lines between 0.000 to 0.005. So between these we can see the divisions of two lines. If I want more divisions, so I will change number of subtricts by values 2, 3, 4. So now in case I select the 4, then I click on data plot. So you can see, so the division is 4 lines. So on the y-axis between 2 points, so the division is divided into in the 4 lines. So it also can use in the x-axis by using this option, and you can show 4 dashes the density of dashes will be very high and will be very different on the mass axis and on the length axis, but it make reading much easier because I go from thousands to thousands, and I can estimate the coordinate of these point and much better. Uh, Finally, we will also introduce here a brief description of experiment determining the spring constant, and using an index we will call the spring constant k index 1. So we will write here description, the indexing done by backslash s, and this one will be index. And to return the normal mode we do backslash n. You see here that is x coordinate and title is fine, but y coordinate will be not okay. For example, here 0.045. So I click on first data plot. Yeah, you can see the x coordinate title is fine, but y coordinate could not be. For example, here 0.045. In addition, we can reduce the size of font and so that the title fit inside the graph. So here y coordinate of title becomes 0.045. Yeah. So we set the position of y and also set the position of x. And we enter the, again, we'll enter the data plot. Yeah. And yeah, you can see our description is mentioned on that same position where we want. Well, and I believe that after this tutorial, you will be able to explore some other function, and you can do experiment and learn more. Yeah, and if you want some, and then yeah, sorry, if you want to click on the calculate how to, where you can find other operation that you can also do some columns using this calculator. So explore here, and font and typeset we use several environment now. \4 is default, and we use \8 to put Greek letter, and \- to reduce. So all detail is mentioned here to put, but you look at all these environment, there is in fact little that you cannot write in Fitteia. So explore the rest by yourself, and we will see you in the next one. Thank you.